Today we are going to start the first exercise of arithmetic progression, and before that I would just like to summarize whatever we have done in our introduction video. Progression is a sequence of numbers which follows a definite pattern. AP is the sequence in which each term differs from its preceding term by a constant. And we also discussed the two types of APs, infinite and finite APs. We also derived the general term of an AP which is given by an equal to a plus n minus 1d. If you are interested to see the introduction video, you can click on the I button. So let's start our first exercise. In this exercise, basically there are two types of questions. In the first type of question, we have to verify or check whether a given sequence is an AP or not. So let me take one example. In my previous video, I have discussed that the terms of an AP are denoted by A1, A2, A3, etc. The first term is also called A sometimes. In order to check whether it is an AP, we are going to find the differences of the consecutive terms. So here the values of A1, A2, A3 are 2, 4, 8, etc. We are going to find their differences in order to check whether they are APs or not. So we find that A2 minus A1 is equal to 4 minus 2, that is 2. A3 minus A2 is equal to 4 and A4 minus A3 is equal to 8. We don't need to find the third value if the first two are coming different, because in an AP the difference should always be same. But I have done it here just to show you. So we can easily decide now that this is not an AP. So children, is the method clear? I think you must be finding it quite interesting. This is a very easy and interesting topic. Let's move on to the next example. So we will repeat our steps. We'll find out the value of A2 minus A1. A2 minus A1 is minus 5 upon 6 minus 1. Minus 1 means plus 1. So it is equal to minus 5 plus 6 upon 6 on taking LCM, and it comes out to be minus 1 upon 6. Similarly, we find the values of the other two and we get that this is equal to minus 4 plus 5 upon 6 on taking LCM. And the third one comes out to be minus 1 by 2 plus 2 upon 3, that is equal to minus 3 plus 4 upon 6 equal to 1 upon 6. So we find that all of them are equal, and this means that this is an AP. Okay, so can you try this one yourself? Yes, try it. Confused? Now all the values are coming equal to 0. 0 can also be the difference. So this is also an AP. Now our next example is a statement question. We have to find whether this situation forms an AP or not. In these types of questions, first we have to calculate A1, A2, A3, etc. So let us take the amount of air present in the cylinder in the beginning be A1, and we can take it as X. Now as the vacuum is removing 1/4 of the air every time, so the remaining air after the first removal will be equal to X minus X by 4, which on taking LCM will become 3 by 4x. Now the amount of air present is this, and from it 1/4 has to be removed, so that means 3x upon 16 is to be removed, and on taking LCM we will get 12x minus 3x upon 16, that is equal to 9x upon 16. Next time it will be 9x upon 16 minus 9x upon 64, which comes out to be 27 upon 64. So the differences will be minus 1 upon 4x. The second difference will be minus 3 upon 16x. As the differences are not same, we don't need to find the third one, and we come to know that it's not an AP. So is it clear to you, children? Let's take another such example. In this we have to find out whether the amount of money in an account every year is in AP when 10,000 rupees are deposited at compound interest of 8% per annum. We have to decide A1, A2, A3, etc. So we'll take A1 as the amount in the beginning. Then we'll find the amount at the end of the first year, which will be the value of A2. As it is compound interest, every time the principal and interest are added to get the next principal. So the value will be P plus PERT upon 100, and on solving we get this value. Same way we will find out the value at the end of the second year, which will come out to be A3. Now I'm not finding A4 here because we can easily see that the values are not differing by the same constant. A2 minus A1 is equal to 800, whereas A3 minus A2 is equal to 864, and so we can easily decide that this is not an AP. So children, is the method clear to you? Okay, now we come to the next type of question where we again have to check that it is an AP, or sometimes it is already given that it is an AP, and then we have to find common difference or first term or 3 more terms, etc. If we are asked to check whether it is an AP, first we will repeat all the steps done in the previous method, and then we will write the common difference and the remaining terms which are asked. Let's consider the first example. In this question, all the terms are same, and we have already discussed that if all the terms are same, then it is an AP. So clearly this is an AP, and the common difference will be 0. And now we have to write the next 3 terms. In order to write the next 3 terms, we can simply add the common difference to the previous terms. As the common difference here is 0, all the remaining terms will be minus 1 by 2. So this was an easy one. Now let us take another example. So first we have to check whether it is an AP. So we will find out A2 minus A1, which is equal to A square minus A. To make it easy to compare with the remaining answers, we will just simplify this a little bit. So I have taken A common, and then it becomes A brackets A minus 1. Similarly, we can find A3 minus A2 comes out to be A square into A minus 1. And A4 minus A3 comes out to be AQ into A minus 1. Again, in this case also, we don't need to find the third one, but I have done this just for your understanding. So we can easily decide from here now that it is not an AP because the values are not coming equal. Okay, third question contains root terms. The basic method will be same. Here A2 minus A1 is root 2. To find A3 minus A2, we have to open the second bracket, and on opening the second bracket, the signs will change, and then 3 and minus 3 cancel, and root 2 subtracted from 2 root 2 gives us root 2. As the first 2 differences are coming equal, so we'll have to find out the third difference also, and we see that the third difference also comes out to be root 2. And so we get that this is an AP. Now as this is an AP, we will have to find the common difference and the remaining 3 terms. So common difference is root 2, as we have already seen. To find out the remaining terms, we can simply add root 2 to the previous terms. So A5 is equal to 3 plus 4 root 2. A6 is equal to 3 plus 5 root 2, and A7 is equal to 3 plus 6 root 2. In the next example, we have root 20, root 45, etc. And you can clearly see that these numbers are containing repeating factors inside the root. So first we will be simplifying these numbers, and 20 is 5 into 4. So 4 will come out and become 2 root 5. In the same way, we can write down the other remaining numbers also, and we get 2 root 5, 3 root 5, 4 root 5, 5 root 5. Okay, let's find out the values of A2 minus A1, A3 minus A2, and A4 minus A3. So you can find again that they are all coming equal, and hence it is an AP. Now the common difference of this AP is root 5. So on adding root 5, we will get the remaining 3 terms, which comes out to be 6 root 5, 7 root 5, and 8 root 5. So children, are all these steps clear to you? If you have any problem, any doubt or any question in your mind, please comment in the comment box and I'll answer you as early as possible. Okay, so I'm giving you one last question which you have to solve yourself just now. I'm waiting. Just try it. Well, if you've completed it, then you can check and find out for yourself whether you have actually understood this topic or not, or you need to again revise it. So that was all for today, children. I hope you enjoyed this video. We will be covering up the remaining questions of this chapter in the coming videos. Till then, take care.